Okay, yes, you can see. All right, I would like to thank Fernando, Javier, Natalie, Zeri for submitting your answers. The rest of you, I do not get your answers there. All right. Now, I'm also going to give everyone my handphone. So, all right, before I forget, so can you make sure you have downloaded the syllabus document and have taken down my handphone number? All right, so that if you wish to, we can keep in touch. Okay, because this is your last set 2 tutorial. All right. So the schedule, the deployment of teachers for subsequent lessons has not been, is still in the process of firming up the deployment. So I have no idea whether I'll be teaching you, continue to teach you, depending on the deployment, all right? So in case I don't teach you, I mean, that is my handphone number. We can keep in touch, okay? So let's continue. All right, so this is the heart. Okay, so this one you must know, even if you don't take pure biology in set 3, set 4, we all have one heart in our body. You must know that the heart has 4 chambers. All right, so the heart has 4 parts, 4 rooms, like room number 1, room number 2, room number 3, room number 4. All right, now you notice that room 1, room 2 is blue color. So can anyone type into the chat or everyone tries? Why is it in blue? The blood that flows through number 1 and number 2, they are in blue. What does it mean when we color it blue? It doesn't mean blue blood. We don't have blue blood. But what does the blue mean? Okay, good job, Javier. So the blue color, right? So the 1 and 2 is actually the deoxygenated blood. All right, that means it's richer in carbon dioxide. Okay, so it's a deoxygenated blood. It meaning that it's less rich in oxygen, instead it's richer in carbon dioxide gas. Then the red color, 3 and 4, obviously is the opposite. All right. Oh, Justine said she messed up a question related to the blood vessel. What is T? T-T means what? Is it like this? Is that supposed to be a cartoon T/T? Or crying face? Okay, don't cry. All right, don't worry. Life doesn't end even if you fail. Let's say even if you touch wood, I'm just saying, even if you fail O-level exam, life will still continue. All right. So over my years of teaching, there are students who may be hardworking, but they are too nervous during the actual O-level exam. They may not do well, but it doesn't matter. In the end, all right, they will still do well in life. Okay, so your life does not depend on just one O-level exam result. It is important. The results are important, but they are not so critical until it determines life and death. It's not a life and death situation. Do you know what is more important in life? When you get your health report, all right, whether, like, for example, whether you should have cancer or not, that kind of result is much more important. Or rather than whether you get A1 or A2. Right, so oxygenated blood, meaning the blood that flows through room number 3 and room number 4 is richer in oxygen gas. All right, is everybody clear? Okay, yes, Javier. All right. Okay, so type your question into the chat or you can unmute yourself. All right, so here from all your body cells, your body tissue will make a lot of carbon dioxide gas. So the blood richer in carbon dioxide gas will flow into chamber number 1, and then it flow into chamber number 2. And then after that, it will go to the lungs. All right, you go to the 2 lungs for gas exchange. Okay, then after that, from your lungs, where your gas exchange, where you breathe in more oxygen, when you breathe out carbon dioxide, then the blood that's richer in oxygen will go to chamber number 3 and chamber number 4, and then it will go up to all parts of the body. All right, my WhatsApp image, yes, is a red puppy that I make at a workshop. All right, so I learned how do you fold a handkerchief into an adorable dog. All right, so that profile photograph in my WhatsApp is a red puppy. That's right. Okay, I'm answering Javier's question in the chat. All right, so please remember the blood flows 1 to 2 and then goes to the lungs. And then from the lungs, it will flow back to 3 and 4 and then go to all parts of your body. So once you know that, in set 3 and set 4, you have to know what is the name of the 4 chambers, right? So this RA doesn't mean restricted artistic, not the new movies or that. This one means right atrium. Right atrium. This one is right ventricle. All right, so this is number 1, number 2, this number 3, number 4. There are 4 rooms, right, in your heart. 4 chambers in your heart. So right atrium, right ventricle, left atrium, left ventricle. Then be wondering, Miss Ivy, I thought our right hand is this, our writing hand is right. How come this one is left? How come this side is left? How come this side is right? Imagine you're a hospital surgeon. You're operating on a patient lying down on the bed. So when the person is lying down on the bed and you open up the heart, right? This is what you see. This will be the patient's right atrium. This will be the patient's right ventricle. This will be the patient's left atrium. And this will be the patient's left ventricle. Is that okay? All right. So the blood go to 1, 2, and go to the lungs for gas exchange. And number 3, number 4. All right. So let me write here. So this is your 1. Okay, maybe I will not. It's actually, okay, 1, 2, deoxygenated blood, then go to the lungs. Then lungs have gas exchange. So richer in oxygen will be 3 and 4. And then it will go to all parts of the body. All right. Okay, so if you accidentally mess up your exam, not to worry. Life, it does not just depend on one exam. Okay, let's start. So here they want the descending blood pressure. All right, in other words, you must start off with the highest blood pressure. Okay, highest pressure to the lowest pressure. Okay, so this part, right, the one that is the lowest, okay, descending means going down. Okay, so the answer for this would be D. All right, so it will be the blood pressure. Hang on, descend. I'll give you this photo that is easier to explain. All right, now over here, let me write the chamber number first. So this is number 1, this is number 2, this is number 3, this is number 4. All right, the one heart got 4 chambers. So then you follow my laser pointer. All right, so the blood, so this is the pressure. This is actually the measurement for the pressure. So actually 4 mm. So basically you must know in the heart there's 4 chambers. There are 2 pumps. All right, so I'm going to highlight the 2 pumps. So you have the, oh, this is not highlighter. All right, so right ventricle is a pump, left ventricle is a pump. But the one that is more powerful pump is the left ventricle. This one is the more powerful pump compared to the other side. Okay, so then look at my laser pointer. So imagine the blood flowing from all, this is all parts of the body. All right, all parts of body that will carry all the carbon dioxide, richer in carbon dioxide blood. That is, we color it blue color, meaning deoxygenated blood. So the deoxygenated blood, the blood pressure is only 4 mm Hg. Hg is the mercury. All right, so this is the blood pressure, unit 4. So pressure is 4, go for the first chamber and then second chamber. Now the second chamber is a pump. When you have a pump, it will pump up the pressure. So from the number 4, at first you started with 4, pressure 4. From pressure 4, it will go to 25. All right, pressure is going up. And then from 25, it will go to your 2 lungs. All right, your 2 lungs. And then after that, it will naturally drop from 25. It will drop to 8. It will then further, all right, as it drops, but then it goes to the left ventricle, which is a more powerful pump. From the number 8, it will go up to 120 in order to be pumped to all parts of the body. All right, so do you notice that our chamber number 4 is a more powerful pump because chamber number 4 bring up the blood pressure from 8 all the way to 120. All right, so chamber number 4 bring up the blood pressure from 8 to 120. All right, so that the blood flowing up from your left ventricle is at the highest blood pressure. 120 is the highest number here because so that blood can, when it's pumped at highest pressure, it can travel to all parts of your body. You can travel up to your brain, you can travel down to your legs from top to bottom. If your blood pressure is very low, then how is your blood going to be pumped to all parts of the body? Cannot, right? So you need the blood to be pumped at highest pressure from chamber number 4. So 120 is the highest number. So 120, 120. Of course, as it goes, slowly pressure will drop. 120 drop to 85. 85 drop to 35. 35 drop to 15. 15 drop to 4. All right, 4, the pressure 4. But then when it comes to the ventricle, this is a right ventricle. Ventricle is a pump, but it's less powerful. It will pump the pressure from 4 to 25. All right, 25, and then go to the lungs. 25 naturally drop to 8, and then at the chamber number 4, from 8, it will go to 120. All right, so is everybody clear? So once you know this pressure, right, so then therefore they want the highest to the lowest, right? So it will be S, all right, then to the P, and then pump, all right, pump to from here. Okay, maybe I'll write it for you. So this is number 1, this is number 2, this is number 3, this is number 4. All right. So the blood from all parts of the body, it will naturally drop, pressure will drop from 1, it will drop to 2, but the 2 is a right ventricle. The right ventricle will pump the pressure, all right, to higher pressure to go to the lungs. Then it will drop to R, and then you go to chamber, from the lungs, you'll go back to chamber number 3, and then to chamber number 4. And then from number 4 is the most powerful pump compared to number 2. 2 and 4 are pumps. Number 4 is the more powerful pump. You will pump up the pressure to the highest pressure. So S must be the highest pressure because S came from chamber number 4. From number 4, after 3, then 4, right? Then the blood will flow out to all parts of the body, including the liver, including your gut of the digestive system. So S is the highest pressure. All right, S is the highest pressure. Okay, highest blood pressure. All right, then from S, it will naturally drop. All right, naturally drop, the blood pressure drop, and then when go to 2, you'll go even higher. All right, but even though higher, it will not be as high as S. You go higher to P, and then as it flow, the blood pressure go down to Q, the blood pressure go down to R. All right, and then go to number 3. Number 4 will bring up the pressure to the highest pressure, S. So the answer is SPQR. All right, is everybody clear? Any questions so far? Please feel free to stop me. Okay, then next question 2 is a matchstick. All right. Now, Kim brought a matchstick close to an extremely hot flame in the open air. Now, this match, right, is not lit up because it does not get hot enough. Okay, it does not get hot enough. So you can watch this video. I did not show you this video just now. All right, so on your own, you can watch the video. It's a very interesting video. So which one is the best conclusion? All right. So here is, in order to light up the matchstick, you need to have heat first. I need heat energy to start the reaction. All right. So in order to have heat, right? So over here, the problem is air is a good insulator. Heat does not flow through air very well. All right. Heat does not flow through air very well. So because there's air here, this is the gap, right? There's air. So even though it's very hot here, but here there's air. So heat from the very, very hot flame does not get conducted very well to the matchstick. All right. So that's why this matchstick does not get hot enough to get lighted up. If this, instead of air, if let's say this is made of, let's say something that is a good conductor of heat, like let's say metal, then heat from the flame will be conducted very quickly to the matchstick and will light up the matchstick. But here is because air does not conduct heat very well. Right, air does not conduct heat very well. Okay, so I'm going to write here, air is a poor conductor of heat. So poor conductor of heat, in other words, is a good insulator. When you say poor conductor, means it's a good insulator. It means the same thing. All right, so poor conductor of heat means good insulator of heat. So it does not conduct heat well to light up the match heat. So this is the match heat here. Okay, any questions? Now, I just want to run through some very interesting facts. All right, so basically a matchstick, right? Here, there's chemical. So it's made out of a fuel and an oxidizing agent. You will learn oxidizing agent in set 4. All right. So basically, I just want you all to know that to appreciate, there are chemicals on the match head. All right, on the match head, this is just ordinary wood. Then on the match box, there's also chemicals here. So of course, you'll notice that it's a bit rough, right? So there's friction. All right. Okay, so there's we put powdered glass here. in order to create friction to generate heat